Hello everyone. Today we're going to be looking at three-sum closest, which is LeetCode problem number 16. This is a medium problem, and it states, given an integer array nums of length n and an integer target, find three integers in nums such that the sum is closest to target. So return the sum of the three integers. We don't need to return the integers themselves, just the sum. And the key word here is closest. It doesn't have to equal the target, it just needs to be the closest to the target. And we can assume that each input has exactly one solution. So if we look at the first example here, we see that nums is -1, 2, 1, -4, and the target is 1. So the output is going to be 2, because according to the explanation here, we have -1 plus 2 plus 1 equals 2. So that's the closest we can get to the target. In the second example, we have 3 zeros, so the closest we're going to get there is just 0. So let's take a look at how we're going to do this. We're basically going to go through the entire array nums. We're going to start at position 0, and we're going to have two pointers. We're going to have a low pointer and a high pointer. So we'll assign the low pointer equal to the next number in the sequence next to the initial number, and then we'll assign the high pointer equal to the last number in the array. And then we'll just add those three together. So we've got 6, -6, -3, plus 5 is equal to -4. So -4 will be our result, current result. And the target we're trying to get to is 0. Well, now -4 is less than the target, so we're going to increment the low. So now we've got -7 plus 5, -2. So now we'll make the result, or the difference, equal -2, which is closer than -4. However, that's still less than the target, so we're going to increment the low again. And so now we've got -6 plus 2 plus 5 equals 1. So now 1 is greater than the target, so we're going to decrease the high value, or the high pointer. So now we have -6 was -1. And the low and the high are now adjacent to each other, so we need to basically increment the initial pointer. So now we're at -3, we'll assign the low and high just like we did before. And there we've got -4 plus 5 is 1. So remember, we're just looking for the smallest difference. We don't care about the actual numbers that add up to that difference. So this doesn't change because it's the same as it always was, even though 1 is also closest to the target. And we're going to increase the low because the last result was -1. And so now we have -3 plus 2, -1 plus, so we have 4. So now we have 2 high, so we got 4 over here, so we're going to decrement the high. And now we've got plus 2, which is still, but because they're adjacent, we're just going to go on to the next one. So the initial pointer is going to be at -1. You're starting to get the idea here. We've got low and a high, and we see that is equal to 6, which is, so now we're going to decrement the high, and we've got 4, and low and high are next to each other, so we can increment 1 here. So basically we've come to the end because the initial pointer is at 2, and the low and the high are going to be 3 and 5, which are adjacent to each other, so it doesn't, there's no need to continue on that path. So let's see how to code this. So the first thing we need to do is create a variable to pass back. So I'm going to create an int, I'm going to call it result, and I'm going to make it equal to, we're going to start at pointer 0, so nums 0. Then we need to add the next number in the array, which would be nums 1. And then we're going to add the last number, which is nums length -1. Because arrays are 0 based. And so that will be our initial result. Now we need to do a sort of that nums that we, up here, that we passed in. And now we just need to start looping through, like we did in the example. So we'll do for int I equals 0. I is less than nums length. Now we're going to do -2. In this case, because we've already taken care of length minus 1, so we don't want to grab that number again. So we're going to do minus 2 and I plus plus. All right, now in here we need a few variables. So now we're going to have our pointers. So we'll make an int start equals I plus 1. Then we can also do the end value here. So end is going to be equal to nums length minus 1. And these are the 2 pointers that we're going to move up and down the array, the low and the high. All right, so while start is less than the end, we're going to do some stuff. What are we going to do? So first we need to create a variable called sum. So this is going to keep track of the addition of the 3 numbers. So we'll have nums I, which is a pointer, and then we're going to just add in nums start, oops, and nums end. All right, so now if that sum is greater than the target, then we need to decrement the end, which moves the high pointer to the right, which we saw in the example. Else, we're going to increment the start by 1. Start plus plus. All right, now we need to compare the sum to the result. So if we're going to do the math absolute, which will get the positive values. So sum minus target. Okay, if that is less than, meaning it's closer to the target, math abs result minus target. Yeah, you know, okay. Then the result is just going to be equal to the sum. Assign some value to the result. All right, so now that we get out of this, at the end we're just going to return result. And that is pretty much the entire program. So let's debug this real quick to see it in action. Okay, I use the first example, -1, 2, 1, and -4, on a target of 1. So we'll start here. Okay, result is -3. We're going to sort the nums value of the nums array, and now we're just going to loop through here. So start will be equal to 1, and end will be equal to 3. All right, so while start is less than end, which is true in our case, the sum is equal to nums of I, which is going to be the -4 plus the -1 plus the 2. So if sum is greater than target, which it isn't, so now we need to increment start by 1. Now if the sum minus target is less than the result minus target, which it isn't, then we will assign result equal to sum. All right, so now we move the start pointer, so now we're just going to check the numbers again. And we see here, what do we have? Start, end. So sum is -1. So we're going to increment the start. And in this case, the sum minus target is greater than result minus target, which is 1, which is result -1. Okay. So now result is -1. And start is not less than end. So basically the start and the end pointers are right next to each other. So we're going to break out of that while loop, and now we're going to go increment the initial pointer. So now the initial pointer becomes 1, and start becomes 2, and end becomes 3. So this one will loop through, add those together. The sum is 2. The sum is greater than the target, which is 1, so we're going to decrement the end pointer. And math abs, sum minus target is less than result minus target. And so the result now becomes 2. All right, and now we're done with that one because the start and end pointer are next to each other. And that is it, because we hit we would have put start up here, and there would have been too much overlapping, or the overlap. So the result here is 2. So if we pass that back, and that is our answer. So let's hope I coded this right. We'll run that, it was accepted, and then we'll submit it. And better than 13 and 18. Let's try it one more time. Sometimes I don't always trust. Well, we're getting better. 30 and memory usage is less than 36. So we'll run with that. Not the quickest solution, but I think it's the most self-explanatory. All right, now let's look at the space and time complexity. For time complexity, a sort of an array is n log of n. But because we're doing a nested for loop, we've got n squared. So this actually trumps the n log n. So the time complexity for this solution is big O n squared. And the space complexity is O of n. So as you increase the input parameter, the logic inside the solution will use more space. And that is it. So thank you for watching. Hope you learned something, and we'll see you next time.